balanced and secure, preventing any structural stress or damage. Floating is crucial as it signifies the ship's readiness for further assembly and installation phases. Following floating, the engine casing is installed. This structure houses the engine and related machinery, providing protection and accessibility for maintenance. The engine casing is constructed and integrated with precision to ensure all components are properly shielded and ventilated. Deckhouse installation at Ulsan Shipyard involves placing the prefabricated structure onto the ship's hull using heavy-duty cranes. The deckhouse, which includes the bridge, command center, and living quarters, is aligned and secured to ensure it integrates seamlessly with the hull. This step is crucial for maintaining the ship's structural integrity and functionality. After the deckhouse is in place, the ship is prepared for launching. This involves moving the ship from the construction site to the water. In Ulsan Shipyard, this can be done via a side launching method or by using a floating dock. The ship is slowly and safely released into the water, marking a significant milestone in its construction. The final step is the sea trial, where the ship is tested in real sea conditions. During the sea trial, various performance parameters, including engine performance, speed, maneuverability, and safety systems, are rigorously tested. This step ensures that the ship meets all regulatory standards and performs as expected before it is delivered to the customer. In just 6 months, the construction of the Inchcape 23, a stunning 23-meter boat crafted from magnesium alloy, was completed. This impressive feat of engineering and craftsmanship involved a meticulous process that began with the selection of materials known for their strength and lightweight. Magnesium alloy, chosen for its durability and resistance to corrosion, was expertly worked into the boat's structure, ensuring longevity and performance on the water. The build process, which took a total of 7 months, involved several stages. Initially, the boat's frame and hull were carefully constructed to provide a solid foundation. Skilled technicians then fitted and reinforced the structure with magnesium alloy panels, followed by precise assembly of the interior and exterior components. Attention to detail was paramount throughout, as each part was meticulously crafted to meet high standards of quality and functionality. Once completed, the Inchcape 23 embarked on her maiden voyage, navigating the scenic Exeter Canal in Devon. This initial journey allowed the team to test and fine-tune the boat's performance in real-world conditions. Following this, the boat was transported to Devonport for its final relocation. To complement the build documentation, 7 additional videos offer 360-degree walkthroughs of the boat's interior, providing an immersive view of the vessel's luxurious and functional design features. The 15,000 TEU LNG vessel represents a significant advancement in maritime technology and environmental sustainability. TEU, or 20-foot equivalent unit, measures cargo capacity. And with a capacity of 15,000 TEU, this vessel is among the largest in its class, specifically designed for container shipping, utilizing liquefied natural gas, LNG, as its primary fuel. This vessel stands at the forefront of the industry's efforts to reduce carbon emissions and promote cleaner energy sources. LNG is known for its lower carbon footprint compared to traditional marine fuels, such as heavy fuel oil or marine diesel oil. It significantly reduces emissions of sulfur oxides, SOx, nitrogen oxides, NOx, and particulate matter, contributing to better air quality and compliance with stringent international regulations like the International Maritime Organization's IMO 2020 sulfur cap. Additionally, LNG engines are quieter and produce less vibration, enhancing crew comfort and reducing marine noise pollution. The adoption of LNG for such a large-scale vessel underscores a commitment to sustainability and innovation. The vessel's design integrates advanced technologies, including state-of-the-art LNG storage and fuel supply systems, efficient dual-fuel engines, and optimized hull designs for enhanced fuel efficiency. This combination of features ensures not only reduced greenhouse gas emissions, but also improved operational efficiency and cost-effectiveness. By offering the cleanest and greenest alternative to traditional ship propulsion, the 15,000 TEU LNG vessel represents a crucial step forward in the maritime industry's journey toward decarbonization. It serves as a model for future vessels, demonstrating that it is possible to achieve significant environmental benefits without compromising on performance or capacity. As the industry continues to embrace greener technologies, such vessels will play a pivotal role in shaping a more sustainable future for global shipping.
Building a cold-molded 22-feet center console boat involves a meticulous manufacturing process that combines traditional craftsmanship with modern techniques. Cold molding is a method of constructing wooden boats using multiple layers of thin veneers, creating a strong and lightweight hull. The process begins with designing the boat, taking into consideration factors such as size, weight, stability, and performance. Once the design is finalized, the next step is lofting, where the boat's lines are drawn full scale on a lofting floor or using computer-aided design CAD software. The keel plays a crucial role in the structural integrity and stability of a boat. It serves as the backbone running longitudinally along the center line of the hull. Typically, the keel is constructed from a solid timber piece that provides strength and rigidity. The frames, also referred to as ribs, are then built and attached to the keel, forming the skeletal structure of the hull. These frames are usually made from steam-bent or laminated wooden strips. Steam bending involves heating the wooden strips to make them pliable and then shaping them to fit the contours of the hull. Alternatively, laminated wooden strips can be used for the frames. In this method, thin strips of wood are glued together under pressure to create a strong and flexible frame that conforms to the desired shape. Laminated frames offer excellent strength and resistance to warping. The frames are strategically spaced along the keel to provide support and maintain the desired shape of the hull. They help distribute the loads and stresses evenly throughout the structure, enhancing the overall strength and durability of the boat. The attachment of frames to the keel is typically done using epoxy resin and mechanical fasteners such as screws or nails. Cold molding is a method of boat construction that utilizes multiple layers of thin wooden veneers to create a strong and lightweight hull. The veneers used in cold molding are typically made from marine-grade plywood or other suitable materials such as mahogany or cedar. Each veneer layer is carefully cut to shape and coated with epoxy resin. The epoxy resin serves as an adhesive, bonding the veneers together and creating a solid composite structure. The veneers are then laid diagonally or at angles to each other during the lamination process. To further enhance the structural integrity, the veneers are fastened together using a combination of epoxy resin and mechanical fasteners like screws or nails. The epoxy resin ensures a strong bond between the veneer layers, while the mechanical fasteners provide additional reinforcement. The use of epoxy resin in cold molding not only acts as an adhesive, but also serves as a protective barrier against water intrusion. By employing multiple layers of veneers, coated with epoxy resin and fastened together, cold molding creates a robust and lightweight hull structure. After the planking process, the hull undergoes fairing and sanding to achieve a smooth and uniform surface. Skilled craftsmen utilize a range of tools and techniques to meticulously remove any imperfections, bumps, or irregularities in the wood. This process ensures that the hull has a seamless and symmetrical shape. Tools such as hand planes, sanders, and fairing boards are used to carefully sculpt and shape the hull. The craftsmen work diligently to achieve a flawless surface, paying close attention to details and continuously checking the hull's fairness and symmetry throughout the process. The result is a hull with a sleek and polished appearance, ready for the next stages of construction. To bolster the strength and durability of the hull in cold-molded boat construction, a layer of fiberglass cloth is applied to the exterior surface of the planking. Fiberglass cloth, known for its high tensile strength, is placed over the hull and saturated with epoxy resin. The epoxy resin acts as both an adhesive and a protective coating. As it cures, it forms a chemical bond with the wood, creating a strong connection and reinforcing the structure. Multiple layers of fiberglass cloth may be applied, with each layer meticulously wetted out with epoxy resin. The fiberglass cloth provides a protective barrier against water intrusion, shielding the underlying wood from moisture and preventing rot or decay. It also adds impact resistance and helps distribute stresses evenly across the hull. By incorporating fiberglass, cloth, and epoxy resin, the hull gains added structural integrity, increased resistance to impacts and abrasion, and improved longevity, making it well suited for demanding marine environments. The first step in building a hull mold is to construct the plug frame. This frame serves as the skeleton onto which the hull shape will be formed. It is typically made of wood or metal and is built according to the specifications provided by the naval architect or boat designer. Once the plug frame is securely in place, the process of attaching planks begins. These planks serve as the primary structure and form for the mold. Typically made of wood, they are carefully shaped and fitted to accurately represent the desired hull shape. The planks are meticulously cut and shaped according to the design specifications, taking into account the curvature and contours of the hull. Skilled craftsmen use various tools such as saws, planes, and chisels to achieve the precise shapes required. Each plank is then securely fastened to the plug frame using screws, nails, or adhesive, ensuring a strong and rigid structure. Great care is taken to align the planks correctly and maintain the intended hull shape throughout the process. As the planks are attached, they gradually form the hull's framework, providing the necessary structure for the subsequent steps. The accuracy and precision of this plank installation are crucial, as any deviations or errors can impact the final shape and quality of the mold. After the planking is complete, the next crucial step in building a hull mold is sanding the entire surface of the plug. This meticulous process is essential to achieve a smooth and uniform finish, eliminating any imperfections or irregularities that could transfer to the final mold. The sanding process begins with coarse grit sandpaper to remove any rough spots, protrusions, or high points on the surface. This initial sanding helps to level out the planks and create a more even base. As the sanding progresses, finer grit sandpaper is used to smooth out the surface further. This step helps to refine the contours and curves of the hull, creating a sleek and precise shape. The sanding is typically done by hand or using sanding blocks to maintain control and precision. Once the surface of the plug has been filled and sanded to perfection, the next step in building a hull mold involves applying a primer. The primer serves as a base coat, providing several important benefits for the mold construction process. The primer is typically sprayed onto the plug surface using specialized equipment. It is a specially formulated coating designed to enhance adhesion and promote the bonding of subsequent layers to the plug. The primer acts as a bonding agent, ensuring a strong connection between the plug and the layers that will be added. The application of primer has several key advantages. Firstly, it helps to seal the surface of the plug, preventing moisture penetration and potential damage to the mold. Secondly, the primer enhances the surface's texture, providing a better grip for subsequent layers of materials, such as fiberglass or gel coat. This improved adhesion helps to create a more durable and reliable mold. Additionally, the primer helps to create a uniform and consistent surface, ensuring that the subsequent layers are applied smoothly and evenly. It also helps to enhance the appearance of the mold, creating a clean and professional finish. The choice of primer depends on the specific requirements of the mold construction process and the materials being used. The primer is typically selected to be compatible with the subsequent layers and the overall construction process. Once the fiberglass layers are in place, a gel coat layer is applied to the mold. Gel coat is a specialized resin that provides a smooth and glossy finish to the mold surface. It also acts as a protective barrier against the elements. Work begins. Once the fiberglass layers are in place, a gel coat layer is applied to the mold. Gel coat is a specialized resin that provides a smooth and glossy finish to the mold surface. It also acts as a protective barrier against the elements. The assembly process of the Iona P&O Cruises' new flagship indeed involved several stages and collaborations between different shipyards. Let's delve into the details of this complex process. The construction of a large cruise ship like the Iona is a highly coordinated effort that requires the expertise of multiple shipyards specializing in different areas. Each shipyard plays a crucial role in building specific sections or components of the vessel, which are later integrated at the main shipyard. VNBN McNH. Once the major sections are built, they are transported to the main shipyard for final assembly. This integration phase is where the various sections are carefully joined together to form a cohesive and functional vessel. Skilled workers at the main shipyard oversee this process, ensuring precise alignment, welding, and fitting of the sections. At the Neptune Werft, the engine room module was constructed. This module housed the modern power plant that would supply the entire ship with energy, including hotel operations. The power plant was designed to be efficient and environmentally friendly, aligning with the ship's focus on sustainability. Neptune Werft's expertise in building complex engine room modules ensured that this critical component of the ship was constructed to the highest standards. The installation of propellers for a cruise ship like the Iona is a crucial step in the assembly process, as they are responsible for propelling the vessel through the water. Before the installation process begins, the propellers for the Iona are designed and manufactured to meet the specific requirements of the ship. Propellers are typically custom designed for each vessel, taking into account factors such as size, power, and efficiency. Prior to the installation, the shipyard prepares the Iona for the propeller installation process. This involves ensuring that the hull area where the propellers will be mounted is clean and free from any obstructions. The propeller shafts, which transmit the power from the ship's engines to the propellers, are carefully installed in the designated positions within the hull. These shafts are securely fastened and aligned to ensure smooth rotation and minimize vibrations during operation. Once the propeller shafts are in place, the propellers themselves are mounted onto the shafts,